set is nothing but the collection of well-defined objects. The objects may be well-defined, whatever may be the objects, it may be well-defined. So in the roster form, all the elements are set or listed. The elements of the set are listed and being separated by the commas, and they are enclosed between the braces. A set A is said to be a subset of B. If all the elements of A must be the elements of set B, then A is called the subset of B. Hello dear students, welcome to this session of Mathematical Foundation class. I am Mr. Niranjan, Faculty Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. Today in this session, I am going to discuss regarding the second part of the Unit 2. So in the first part, we have discussed regarding the matrices and the determinants. Whereas in the second part, we are going to discuss regarding the sets, relations and the function. That's all. Now let us come to the first concept, set. So you might have been studied in your previous classes regarding a set, definition of a set and example and representation of a set. Let me discuss regarding set. Now what is a set? Actually set is nothing but the collection of well-defined objects. The objects may be well-defined, whatever may be the objects, it may be well-defined. The collection of well-defined objects is called a set. Usually a set is represented between two flower brackets, right? Now in mathematics, sets are the collection of a well-defined objects or elements. So the collection of well-defined objects or elements is called a set. A set is represented by a capital letter or capital symbols, and the elements of the sets are represented by the small letters like small a, small b and small c. So the capital A, capital B, capital C will represent the representation of a set, and whereas the elements small a, small b, small c are called as the elements of the set. So a set is represented by a capital letter. Let us take an example. A is equal to a set which contains A, B, C, D. Here A, B, C, D, four elements, four letters of English alphabet, A, B, C, D, first four letters. So A is the capital A represents the set, and small a, small b, small c represents the elements of the set. Now suppose if A is contained in the set A, means we can represent it as A belongs to the set A, small b belongs to set A, and similarly small b belongs to set A. Suppose if the element does not belongs to the set, say for example E does not belongs to set A, therefore which is denoted as E does not belongs to A. Okay, this is how we are going to represent. So A belongs to and does not belongs to. If any element belongs to the set, that is represented like this, belongs to. This means belongs to, element belongs to or contained in the set. This means does not belongs to. The symbol for does not belongs to, does not belongs to. Right. Now, so in general, a collection of well-defined object is called the set. The set is usually represented by the capital letters, capital K, capital B, capital C, and similarly the elements of the set are represented by small a, small b, small c. Okay. Now, or if a set contains the numbers, suppose let us consider a set contains numbers 1, 2, 3 and 4. So this is also an example for a set. Now let us know regarding the usual general representation. So in mathematics, we usually represent some standard sets like the set of all natural numbers is denoted as n. N is the set of all natural numbers which contains the counting number, all positive numbers 1, 2, 3, 4, etc. The set of natural numbers is denoted as n, which contains all counting numbers 1, 2, 3, 4, 5, etc. The set of integers is denoted as z or I. I or z is denoted as, will represent the set of integers. The set of integers is denoted as I or z, which contains 0 as well as all positive and negative numbers plus or minus 1, plus or minus 2, etc. This is an example for a set of integers. So usually the set of integers are denoted as I or z. Next, the set of rational numbers is denoted as Q. Q is a set of rational numbers. The set of rational numbers is of the form P by Q, where P and Q belongs to any integer and I and Q is not equal to 0. Any numbers of the form P by Q is called a rational number where P and Q belongs to any integer and Q is not equal to the 0, Q is not equal to 0. And the set of real numbers, so the all numbers which comes under discussion except the complex numbers will comes under this set of real numbers. So the set of real numbers is denoted as R. R is the representation of a set of real numbers, whereas the set of complex numbers is denoted as Z. C is the set of complex number. So any numbers of the form x plus iy, where x and y belongs to any integer, x and y belongs to any integer, and I is equal to root of -1, an imaginary number. So this is how we are going to represent the set. So the set of natural numbers as n, and the set of integers as I or z, the set of real numbers as r, and the set of rational numbers as q, and C is the set of all complex numbers, right? This is how we are going to represent. So these are the representation of some standard sets. Now let us know regarding the representation of sets. In the sets are represented in two methods. The very important methods are roster method and the set builder method. Roster method, or it is also called as tabular method. Usually a set is represented in two ways, two methods. So the first one is the roster method or tabular method, that is roster form or tabular form, roster method or tabular method, and the second one is called as the set builder form or set builder method. Now let us know in detail what is this roster form or tabular form. Now first one is the roster form, or it is also called as the tabular form. So in the roster form, all the elements are set or listed. The elements of the set are listed and being separated by the commas, and they are enclosed between the braces, so between the two flower brackets. Let us take an example. The set of letters forming the word school, S-C-H-O-O-L. So this contain S-C-H-O-L. Just avoid the repetition. Let us take one more example. Let us consider a set A. If A contains the elements of the set mathematics, M-A-T-H-E-M-A-T-I-C-S. The elements of the set, say M, A, T, H, comma E. Already we have M, A, T is taken, I, then C and S. So these are called the elements of the set which are in the roster form. So the elements of the set are just listed, they are listed and they are separated by the commas and enclosed between the two flower brackets. This is an example for the set in roster form. So the set of letters forming the word school or the set of letters forming the word mathematics is an example for a set in roster form. Now let us come to the second one. Second one is the set builder form. Here in set builder form, the elements of the set are listed according to some property or according to some given statement. So the elements are arranged according to the given statement. That is, in set builder form, all the elements of a set will possess a single common property. So it will possess, all the elements will possess a single common property which is not possessed by any element outside that set. So which is not possessed by any element outside that set. So let us consider, for example, if A is equal to X such that X is a natural number and X lies between 3 and 3. So how to read this? This is read it as the set of all X such that X is a natural number. The set of all X such that, X is a natural number and X lies between 3 and 4. So the value of X which lies between 3 and 4. So here 3, 4, 5, 6, 7, 8, 9 and 10. So the elements which lies between 3 and 10, in between 3 and 10 are these elements. So the elements which lies between 3 and 10, all the natural numbers. So therefore the numbers are 4, 5, 6, 7, 8 and 9 will form the elements of the set. So therefore the set A is equal to 4, 5, 6, 7, 8 and 9. These are the elements of the set. So this type of representation is called the set builder form. That means here the elements of the set will possess a single property or the elements of the set are arranged according to the given statement or given definition. So this is an example for a set which is in the set builder form, that is set of all natural numbers which lies between 3 and 10 or 4, 5, 6, 7, 8 and 9. That's it. Now, let us come to the next concept, finite and infinite set. Finite set and infinite set. Finite set, these are all basics. Actually, the syllabus starts from a power set. So, exactly going to the definition of power set, let us know regarding few definitions. Now, finite set and infinite set. A finite set, a set consisting of a definite number of elements is called a finite set, and otherwise it is called an infinite set. A set which contains infinite number of elements is called an infinite set. Let me take an example. A set which contains definite number of elements is called a finite set. All counting numbers. Let us consider A is equal to 1, 2, 3, 4. This is an example for a finite set. Another set, let us consider one more example for a finite set. Set of all letters in an English vowel A, E, I, O, U. This is an example for a finite set. It contains finite number of elements. On the other hand, let us consider another set. Set C is equal to 1, 2, 3, 4, etc. This is an example for an infinite set. So let me take one more example. Set of all even numbers, that is 2, 4, 6, 8, etc. So this is an example for infinite. So here the number of elements are not definite. Here the number of elements are definite. So the number of elements in this set contains 4. The number of elements in this set is 5. Whereas the number of elements in that set is infinite. So therefore, these are an example for infinite sets and these are example for a finite set. So usually the number of elements in a set is denoted as n of A. The number of elements in set is 4. Here the number of elements in set B is equal to 5. So therefore this is the finite set, whereas the number of elements there is not defined. They are infinite. Therefore it is an example for an infinite set. So finite and infinite sets. Now by knowing this, let us know regarding equality of set, equal sets. When did you say two sets are said to be equal? So two sets A and B are said to be equal if they have the same elements, exactly the same and the same number of elements. So if the number of elements in two sets are same and equal, then they are called as equal sets and denoted as A equal to B. Otherwise the sets are said to be unequal set, denoted as A is not equal to B, not equal. So two sets are said to be equal if and only if they will have the same elements and the same number of elements. So if the number of elements in both the sets are same and equal, then the two sets are said to be equal sets, denoted as A is equal to B. If the number of elements are not equal, then we are represent as A is not equal to B, not equal set. Let us take an example. A is equal to 1, 2, 3, 4. B is equal to 3, 4, 1, 2. A is equal to B. Whatever may be the order of the element. So that is whatever may be the place of an element. So here number of elements in A is 4 and the number of elements in B is also 4. N of A is equal to 4 and the number of elements in B is also equal to 4. Whatever may be the position. So here 1, 2, 3, 4, here 3, 1, 4, 2. So A contains 4 elements, B contains 4 elements, A contains 1, 2, 3, 4, B also contains 1, 2, 3, 4. Therefore, A and B are said to be equal. Let us take one more example. Let C is equal to 1, 2, 3, 4 and D is equal to 1, 2, 3, 4, 5. Right. Let us take another example. Let C is equal to 1, 2, 3, 4 and D is equal to 1, 2, 3, 5. So here AC is not equal to D. Since the number of elements in C is equal to 4 and the number of elements in D is also equal to 4, the number of elements are same, but the elements are not same. Here 1, 2, 3 we have. In set we have 4. 4 belongs to C, whereas 4 does not belongs to D. Similarly, 5 belongs to D, whereas 5 does not belongs to D. So here 4 is there, but 4 is not in the set D, whereas 5 is in the set D, but 5 is not in the set 4. So 4 and 5 are different elements in both the sets. So therefore, these two sets are said to be not equal. They are not equal, but equal in size, but not equal. Equal in size means the number of elements in both the sets are same. That is, if number of elements in set A and set B are same, set C and set D are same. If the number of elements are same, they are said to be equal in size. If the number of elements are same and the same number of elements are present, then the two sets are said to be equal. That is regarding equality of sets. Now, so here just we will have an example. In the examination, they may ask for 2 marks. If two sets like this, x plus 2 comma y plus 4 is equal to 6 and 7. Find the values of x and y. So then how to find x? X plus 2 is equal to 6 and y plus 4 is equal to 7. From this we can write x is equal to 6 minus 2, x is equal to 4 and y is equal to 7 minus 4, that is y is equal to c. So the value of x and y is 4 and 3. If you add 4 plus 3, what you will get? So therefore the value of x is equal to 4 and y is equal to, x is equal to 4 and y is equal to 2. So if you substitute x is equal to 4 here, 4 plus 2 is 6. If you put x is equal to 3, 3 plus 4 is equal to 7. So that is regarding equality of sets. Now by knowing this, let us know regarding the next concept. This is very important, subsets. So from here actually the syllabus will start for from here actually the syllabus for first semester B.Ca of unit 2 will start, that is subsets, then power sets. What is a subset? A set A is said to be a subset of B if every element of A is also an element of B. If all the elements of A must be the elements of set B, then A is called the subset of B, right? A set A is said to be a subset of B if all the elements of A must be the elements of set B, then A is called the subset of B. That is, a set A is said to be a subset of B if every element of A is also an element of set B, and it is denoted as A is the subset of B. So if A belongs to A, implies A also belongs to B. So if A belongs to A, then A also belongs to B, then A is called the subset of B. Now let us take for example, the set of all natural numbers is the set of all real numbers. Now one more example. So that is denoted as the set of rational numbers is denoted as Q and the set of real numbers as R. So therefore the set of all rational numbers is the set of all real numbers, which is denoted as Q is the subset of R. Let me take a general example. Let A is equal to 1, 2, 3, 4 and B is equal to 1, 2, 3, 4, 5. Here A is the subset of B. A is the subset of B because all the elements of A. What is A contain? A contain 1, 2, 3, 4. All the elements are the elements of the set A 1, 2, 3, 4. All the elements of A are the elements of set B. Therefore, A is the subset of B. See here, A contains 1, 2, 3, 4. B contains 1, 2, 3, 4, 5, 6. So therefore, A is the subset of B. Similarly, let me take one more set. So if C is equal to 4, 5, 6, 4, 5, 6, then I can say C is the subset of B. C is the subset of B because all the elements of C is nothing but the elements of B. So therefore C is the subset of B. Even if I take D is equal to 1, 2. So this D is the subset of B because D contains 1, 2. All 1, 2 is included in the set B. Therefore D is the subset of B. So if all the elements of set A are the elements of set B, then A is called the subset of B. Okay. Now let us know regarding proper subset and superset. Superset and proper subset. Let A and B are two sets if A is a subset of B and A is not equal to B. If A is the subset of B and A is not equal to B, then A is called the proper subset of B. If A is the subset of B and if all the elements of A are not equal to elements in B, then A is called the proper subset of B. If A is not equal to B, then it is called the proper subset and B is called the superset of A. Whereas B is called as the superset of A. So let A and B are any two sets. If A is a subset of B and A is not equal to B, then A is called the proper subset of B and B is called the superset of A. Now let us take an example. If A is equal to 1, 2, 3, so then 1, 2, 3 is the proper subset of B. A is the subset of B because all the elements of A are the elements of B. 1, 2, 3 contained in A. 1, 2, 3 is also in the set B. Therefore, A is the subset of B. Since all the elements of A are not equal to the elements of B, just only 1, 2, 3 is there, whereas 4 is not included in the set A. Therefore, this is an example for a proper subset. Now, let us take one more example. If A is equal to 1, 2 and B is equal to 1, 2, 3, then A is also a proper subset of B, because the elements of set A are the elements of B. That is, A contains 1, 2, B contains 1, 2 and 3. So, therefore, this is the proper subset and it is denoted as A is the proper subset of B. Right. Now, let us take an example. Before that, now this is let us come to the next concept. This is very important concept, power set. You may expect one question for 5 marks from power set. Very important concept. Now, power set means the collection of all subsets of a set. The collection of all the subset of a set is called the power set. Suppose if A is a set, then the collection of all the subset of a set A is called the power set of A, and it is denoted as P of A. So, P of A will give the power set. Now, let us take an example. If A is equal to 1, 2, then the subset of this is denoted as P of A. That is, the subset of A is equal to 1 element, then 2, then 1, 2, and then null set. These are all the subset. Null set is also a subset of the given set. So, the power set, how many sets are there? The power set of A is equal to 1, 2, 3, 4. So, it contains 4 elements. Right. This is how we are going to write the power set. Power set is the set of all subset of the given set is called the power set, denoted as P of A. Now, there is one general formula. Suppose if a set A contains, in general, that is number of elements in the power set. Number of elements in the power set. For number of elements in the power set, there is one general formula. In general, if a set A contains n of A, that is n of A contains m elements, the number of elements in set A is m, then the number of elements in the power set is denoted as n of P of A is equal to 2 to the power of n. The number of elements in the power set is always equal to 2 to the power of m. 2 to the power of m number of sets will be there in the power set. So, if a set contains m number of elements, the number of subsets is equal to 2 to the power of m. So, if a set contains m elements, then the number of subsets, that is the power set, is given by n of P of A is equal to 2 to the power of m. A set Z contains 4 elements, and the number of elements in the power set of Z will be denoted as n of P of Z is equal to 2 to the power of n. That is nothing but n of P of Z is equal to 2 to the power of n. What is n here? 2 to the power of 4. 2 to the power of 4 is equal to 16. So, it contains 16 subsets. So, in the previous problem, what is the previous problem? We have taken in the previous problem here, number of elements are 2 elements. So, therefore, the number of subsets, the power n of P of A is equal to 2 to the power of 2. 2 to the power of 2 is nothing but 4. That's all. 2 square is equal to 4. 1, 2, 3 and 4. That's it. Right. Now, by knowing this, let us take very important problems. In the examination, they may ask for 5 marks. Define a power set and write the power set for the given set. So, in the examination, they will ask the question like this for 5 marks. Sometimes you may expect for 7 marks also. Define a power set and write the possible power set for the given set for 7 marks also. Now, write the power set of the following sets. So, A is equal to 1, 2. The number of subsets. So, power set, number of subset of A is, A contains 1 and 2, therefore, it contains 1, 2, then the set itself 1, 2 and the null set. Null set is also a subset. So, therefore, it contains 1, 2, 3, 4. The number of subsets of A is equal to 4. This is the power set. Power set of A is 1, 2, 1, 2 and null set. Now, let us take this element. B is equal to 1, 2, 3. So, B contains 1, 2 and 3. Write down all the possible subsets. So, the subset of B. So, first write down first element 1, then 2, then 3, then 1 comma 2, 1 comma 2, then 2 comma 3, then 1 comma 3, then the set 1, 2, 3 and the null set. These are the power sets. See, so how many elements are there? N of P of B is equal to 2 to the power of 1, 2, 3. 2 to the power of 3 is 8. Check whether it contains 8 subsets. 1, 2, 3, 4, 5, 6, 7, 8. So this contains 8 subset. This is called the power set. The number of elements of the power set, the number of elements of the set B is 8 sets, that is 8 subsets are there. So this contains 8 subsets, that is the power set. So if B is equal to 1, 2, 3, 4, if B is equal to 1, 2, 3, then the possible subsets are 1, 2, 3, 1 comma 2, 2 comma 3, 1 comma 3, 1, 2, 3 and a null set. Okay. Now let us consider this element C. Let us consider this set. C is equal to A, B, C, D. Write all the power set of this now. Yes, what is C? Come to the third one. C, that is A, B, C, D. A, B, C, D. So how many elements are there? 4. Number of elements in C. N of C is equal to 4. So therefore, power set of C is equal to 2 to the power of 4. 2 to the power of 4 means 16. 2 to the 4, 4 to the 8 to the 16. Let us check whether we will get 16 subsets or not. First one, A, okay, then B, then C, then D. A, B, C, D. Now take two elements, A comma B, A comma B, then A comma C, then A comma D. Okay. A comma B, A comma C, A comma D. Then again take B, B comma C, then B comma D, B comma D. Okay. Then take C, C comma D, C comma D. Check where anything is, if at all anything is repeated, A comma C, no, A comma D, so B comma C, B comma D, C comma D. Now we can take three elements, A comma B comma C, A, B, C, then A, B, C, then A, C, D, A comma C comma D. Okay, A comma B comma C and A comma C comma D. Again B comma C comma D, B comma C comma D, B, C, D. Then C, D, A. Already there is no chance of taking C, D, A, C, D, A because already A, C, D is there. And then the whole set, that is A, B, C, D and the null set. Let me check. A, B, C, D, A, B, A, C, A, B. So first one element, two elements are okay. Now check first A, B, C, then A, C, D, A, C, D, B, C, D. Again I can take A, B, D, A, B, D, then the set A, B, C and null set. Now check how many elements are there. So here 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and null set 16. So the number of subsets of C is equal to 16 subsets. So this is how we are going to write the number of subsets. Now suppose if, say for example, if a set contains the numerals like A is equal to 1 comma 2, the number of subsets is nothing but 2 to the power of 2, that is the power set of A can also be written as set 1, set 2, that is set containing 1, first 1, 2, then 1 comma set 1 comma 2 and the null set. So there are 4 subsets. So how many subsets are there? So which implies n of P of A is equal to 2 to the power of n, that is 2 square. 2 square is equal to, so it contains 1, 2, 3, 4 subsets. This is how we are going to write the subset. So the number of subset including the null set and the set is called the power set. Okay, null set and the set is also a subset. So power set of number of elements containing n or m is 2 to the power of n or 2 to the power of m. So very important concept. You may expect one question from this. power set for your 5 marks in the final examination. So that's all regarding the basic concepts of definition of a sets and the representation and the power set. In the next class, I am going to discuss regarding the operations and very important concept, Venn diagram. Don't miss the class, attend the class. That's all. Thank you very much.